Hi and welcome to the presentation for short answer question 3 of week 6 tutorial. We're going to run through the answer to these questions here. The first one, first of all, the equation here being wage, which is dependent on the following variables. We've got education represented in here, experience, as well as a combination factor, and also hours worked. So they're the main factors we're going to be comparing during this question, and their effect directly to wage. So first of all, question A is basically running through using an approximate t critical value of 2. What are the coefficient estimates not significantly different from 0? So to do that, we're going to have to hypothesis test each value, each of the betas. So first of all, we're going to test B1, and to run through that, we've got a standard hypothesis test, and we go through test statistic, which is relevant there. So for one coefficient, we use a t-test. We're given that Tc equals 2 at the 5% significance level. We can work out our rejection regions. So if we've got t being greater than Tc, or 2, then we can reject the hypothesis, the null hypothesis. Otherwise, if it's less, we are not able to reject it. We run through the calculations using this formula here, which is the standard t-test formula. So we run through that and we get a value of 0.9479. The conclusion being as the t-value is less than the t-critical 2, we aren't able to reject the null hypothesis that beta 1 equals 0. So this means we can't prove that beta 1 is not significantly different from 0. So we repeat this with the beta 2, and we run through that, and we get, in this instance again, we don't have significant evidence to reject the hypothesis, the null hypothesis of beta 2 equaling 0. So again, we can't prove that it's not significantly different. And we run through with beta 3, 4, 5, 6, and 7. So in summary, we've got beta 4 and beta 7 that have proven to be significantly different. And then we've got the other betas that don't have any evidence to suggest otherwise. So that caps off question A. The next question runs through what restriction on the coefficients of equation A gives equation B. We're going to use an f-test to show that restriction, and we're also to test the restriction. We're also going to show how the same result for that f-test can be found using a t-test, because we've only got one variable that we're actually testing. So we've got equation A here, includes all 7 beta 1 to beta 7. Equation B removes beta 6, the experience versus education factor, or experience times education factor. So we're going to run through the answers to that one here. So we've got our unrestricted model of equation A. By removing beta 6 from the model, we get equation B, which is our restricted model here. So there's no beta 6 there, which is experience times education. So to test this using an f-test, we run through the hypothesis, we get the test statistic. So using the f critical value required, we end up with a value of 3. We find our rejection region again. We calculate using the formula here. So we've got our sum of standard errors for the restricted model being equation B. So we find this value here, minus the sum of standard errors for the unrestricted model being equation A, and that is this value here, divided by J, and J being the number of restrictions, so in this model is 1, so we've got a 1 here, divided by, again, sum of standard errors unrestricted model over n minus k, so number of data minus the number of parameters in the equation, which is 7. So that gets us an f value of 1.1186, and as f of 1.1186 is less than the f critical of 3, therefore we don't have evidence to reject the null hypothesis that B6 equals 0. We can also get this same result using a t-test. and that runs through very similar as above using the t-test instead. So we get a t-value here, t-critical of 1.645. We run through again rejection regions. Using this formula here, we're able to calculate that the t-value is 1.25, and again, the t-value 1.25 is less than the t-critical value. So we don't have evidence to reject the hypothesis that B6 or beta 6 is 0. Meaning that we can't reject that experience times education is a relevant indicator. The same result as the F-test. So, question C is what restrictions on the coefficients of equation A give C, equation C. And we're going to use an F-test to test these restrictions, and we can't use a T-test because there are more than one variable we're testing now. And then the other answer we're going to give is what question would you be trying to answer by performing this test. So the question we're going to be answering is experience significantly related to an increase in wage amount? So we're testing equation A, removing experience squared, and experience times education. So we're removing beta 4, beta 5, and beta 6. So beta 4, beta 5, beta 6 are removed from the unrestricted model, which is equation A, and then we're left with the restricted model, equation C. Now to test this, we use an F-test. So we're testing the hypothesis that these have been removed here. We are running through a test statistic of F critical equaling 2.6. We have our rejection regions notified there, and the calculations which come about the same way as previously. So sum of standard errors of the restricted model is now equation C, value here. Sum of standard errors, squared errors, is for the unrestricted model is 222.41. It's the same as this value here, equation A. So we've computed all of that here. In this term here, we've got J equaling 3 because there are now 3 restrictions that we're testing, and then N minus K remains the same, and the sum of squared errors for unrestricted is the same as over here. So the F value we get is 2.1059. As that is less than 2.6, our critical value, we don't have evidence to reject. So we can't prove that these statistics are significant at the 5% level. So removing experience squared, and experience times education has not been determined to be effective. The next question we have is now we're going to compare equation B to equation D. So what we do here is the unrestricted model of B, which we've found above, and we're going to remove beta 2 and beta 3 as determined in the table here. So we've got a new restricted model, equation D, that focuses on experience and hours worked. So the question is education significantly related to an increase in wage amount? We're going to have to use an F-test again, as we're testing two separate variables there. So our F critical value 3, run through the same again. We end up with an F statistic, an F value of 129.10, which is considerably larger than the F statistic there, the F critical value. So therefore we do have quite significant evidence to reject the null hypothesis. So the evidence does suggest that education is very significant at the 5% level, leading us to believe that education is essentially very relevant to wage. So using that information here, we move on to the next one, number E. So what restrictions on the coefficients of equation A give E? So we're running through unrestricted model of A, removing these two beta 3 and beta 6, and we end up with model E, which focuses on education, experience, and hours worked. So the question is, will removing the quadratic equation and experience times education elements help the model become more accurate? So we use an F-test again, run through FC value is 3, and then our F value is 2.73, so we don't have enough evidence to reject the null hypothesis in this instance. So we can't prove that these statistics are significant. Removing experience squared and experience times education from the equation has not been determined to be effective. Although it's reasonably close to the FC value, showing that the quadratic equation and experience times education elements may be significant potentially at a higher level of significance. So the next one here being F. So based on our answers to parts A to E, which model would you prefer and why? So based on the answers, we found that education and education squared are very significant. Due to the results in B, we found that, question B, we found that experience and education had little evidence of significance. Therefore, the model A, which encompasses those variables, or that variable, has been excluded. Due to the results in C, we found that experience elements had no strong relation to the model. Looking at equation D and E and taking into account that neither have a strong presence of education, we can omit these two. While we have no evidence to suggest that experience is not a factor in wage increase, the data in C and E both suggest that while experience is not significant at the 5% level, it isn't far off and may well be significant at a 10% level, suggesting that experience would be an element in the equation worth keeping. In summary, the two best equations are equation B and C, for they both have a strong presence of education and also experience. So in order to know which is best, I suggest testing as follows. So we have an unrestricted model of equation B versus essentially removing experience from that to test whether or not experience is worth having or not. So we use an F test, and we find that there is strong evidence to reject the null hypothesis. So there is a large factor that experience has in wage. Therefore, I'm suggesting equation B, because equation B here encompasses education and experience and hours worked, which we found are all key to wage increase. Thanks again.